Hello there. In this video, we're going to talk about, again, the confidence intervals for the population proportion. In the last video, we pretty much derived how to construct a confidence interval for the proportion. In this video, we're going to work through an example to sort of demonstrate how one is constructed and how to interpret it. So let us briefly go over those concepts that we talked about. So the big assumption here is that n is sufficiently large. If n is not large, then this test might give a lot of misleading interpretations and sometimes completely wrong interpretations. If you look at the derivation for this confidence interval, this was derived based on two interpretations. One, n is large, allowing us to use the normal distribution to approximate a binomial distribution. And we also made the assumption that the sample proportion is a decent estimate for the population proportion. So it's pretty much error built on error if these assumptions are not met. So these assumptions are very important. And we're going to look at the two-sided alternative hypothesis. So somebody's going to claim that the proportion is equal to some percent. And our simple alternative is that the proportion is not equal to that specified percent. So, of course, since the specified variable associated to this distribution is approximated to be normal, then a z critical value is going to be the critical value that we want. And so the symmetric interval for confidence for pi is going to have this marginal error relationship. All right, so let's work through an example to sort of see how to work this out. So let's suppose you conduct a survey. And you ask them, what is your smoking habits? So we're going to ask a number of people who smoke in your community. And also record the gender for the participants. And let us also suppose that we are going to work on our statistical level of 0.02. So the probability of making a type 1 error is going to be 2%. So if we make that assumption, we're going to let C be equal to 98. So we're going to construct a 98% confidence interval for the population proportion of something. So let's assume that we get the following data. So let's assume we have two gender categories, male and female. And we have two categories for smoking, smoke or does not smoke. All right, let's assume that we get these following categories. So 127, 82 in some community, 523, and 672. All right, so let's assume that we want to test the null hypothesis, that the population proportion for our community of people that are male and do not smoke, this proportion is equal to 40%. So this is just some shorthand notation. Male, doesn't smoke, in community. So the community is pretty much acting like the population here. All right, so the alternative hypothesis for this hypothesis test is going to be equal to this population proportion for the community. You don't really have to write C. Males that do not smoke is not equal to 40%. So this is the hypothesis test that we're going to sort of conduct here. All right, so let's go back to our table and just add up a couple things. So let's see. So 127 plus 82, that's going to be equal to 209. 523 and 672 is going to come out to 1195. And if we add across the rows, then that's going to give us 650 for the first row. That's going to give us 754 for the second row. And if we add up either all the rows or all the columns together, we should get 1404. So this is going to be my sample size. So of course, you may claim that this is a large number. So we should have no issues with the conclusions for this hypothesis test. All right, so what is the sample proportion that we're interested in? So we're interested in males and those who do not smoke. So the proportion associated to that is equal to what? So according to this table, the males is in row 1, the not smokers in column 2. So 523 is going to be the value of interest. So this is going to be x over m. So this is going to be equal to 523 divided by 1404. And if you divide that out, then you're going to get something approximately equal to 0.373. So somebody claims that the population proportion is about 40%. You get something that's about equal to 37%. So you may think, okay, maybe they are close. But based on our level of confidence and the confidence interval, is this really the conclusion that we're going to get? All right, so let's go through that. All right, so let's get our confidence region. So the confidence level by assumption is 98. So you should be able to find that the critical value associated to that. So if you're in Excel, you can find this by norm.s.imv of 1 plus 0.98 divided by 2. So that's your 1 plus c over 2 relationship. So your critical value associated to our confidence interval is going to be about 2.326. Okay, so with that being said, then I can calculate my marginal error for my confidence interval. So recall that's going to be the critical value times the square root of the sample proportion of success times the sample proportion of non-successes divided by the total number of people sampled. So once you plug everything in, that's going to give us 2.326 times the square root of see 0.373, then 1 minus 0.373, all divided by 1,404. So once you do that calculation out, you should get something about equal to 0.03. So that's your marginal error. All right, so we're going to look at our sample proportion, so 0.373, and we're going to add and subtract this marginal error to see what we get for our confidence interval. All right, so the confidence interval for the proportion of males who do not smoke under a 98% confidence region is going to be equal to 0.373 minus the marginal error, comma, the sample proportion, 0.373, plus the marginal error. And this is going to be equal to 0.343, comma, 0.403. So this is my confidence interval. All right, so let's go back to pretty much what we were talking about. So the null hypothesis was that the population proportion of people who are male and do not smoke is equal to 40%. So 40% is in this confidence interval, right? So since the null hypothesis proportion lies within our confidence interval, that means what? Well, that means our sample pretty much agrees with what they say. So that means I do not have enough evidence to reject the null hypothesis. So I'm going to fail to reject the null hypothesis because I'm 98% confident that the proportion should be in here, which doesn't really disagree with what they say. Now, of course, you may be very observant here. 0.4 and 0.430 are, I guess you could call, very approximately equal to. So you may, in the back of your mind, be say, okay, well, this is negotiable, right? So recall that this conclusion. So recall the CI is based on a sample. Hopefully this is a simple random sample. But nonetheless, this is based on a sample, so maybe this is a bad sample. Maybe it's not well representative. But if it's truly a random sample, then you shouldn't really question anything of the sorts, because any sample is a fair sample as long as those assumptions are made clear. Like, everybody's independent, it was simple, it was random, and so forth. But you at least can make this observation that the boundary of the confidence interval is close to the null hypothesis. So even though you are failing to reject the null hypothesis, you don't really have strong evidence to sort of fail to reject the null hypothesis. Because if you change your level of confidence to something else, then you might be able to reject it. But the evidence you have is pretty weak. But at least, be open-minded, especially when your null hypothesis is close to the boundaries. Always keep that in mind. But that's pretty much how you use confidence intervals to test null and alternative hypotheses for the population proportion.